Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Commercial LEO Destination or CLD contract from NASA. So let's dive right into it. Now, what is exactly the problem that NASA is giving this contract? Well, astronauts are spending more time on ISS rather than doing things in ISS. So basically, ISS at this point in time is starting to break down. Like we have started to see that, like a few years ago, basically where their thermal system is breaking, power inverters are breaking, this is breaking, that is breaking. They have air leaks, literally air leaks, and these things are becoming more and more frequent. So basically this puppy is reaching its end of life, and at this point in time the importance of this puppy cannot be understated, simply because it's only, like at this point in time, the only permanent microgravity research, basically zero gravity research. Now you may be like, why do you need that? Well, there are many things that can be done in zero gravity and which we have to figure out, because like it's an unknown environment. We have to do things to figure things out. Like for example, you can make fiber optics there that are 100 times better than any fiber optics manufacturing technique that you can develop on Earth, simply because of lack of gravity. Now how would you know that? Unless you have a permanent microgravity research lab like ISS. Now ISS allows us to do many things that we flat out did not knew. We flat out did not know what is the effect of long-term low gravity. So all these things combined create it is a very valuable tool. However, it's very old and outdated, meaning, like, to give you a context of that, they have recently replaced the solar panel, and technological development in next 20 was like basically 20 years of service life was so high that the solar panels now they have added, it's smaller, yet it has more power. So let that sink in. So small air leaks at this point in time is almost normal. Like literally, if you look into NASA system, they're like year one incident, year two incidents. It's like it's keep increasing it. And again, be mindful. The system is designed and with enough robustness that it can handle that. But it becomes an annoying thing. Basically, it's like you're patching it up more than you are spending time doing research. And funding is only fixed till 2024, meaning after 2024 renegotiations have to be done by all the countries involved in this puppy, unless some country want to bear more burden that they can handle. For example, USA and Russia, they must bear the load, otherwise flat out this project will be cancelled. Then you have basically JAXA, and you have Canada. All those things considered, like there have to be a big round table discussion about how to proceed after that point. Like till 2024 they're good, they're settled, but they don't even want to continue it after 2024, simply because it's too old, too damaged, and like again it has served us quite well, and it's like it's showing its age. So solution that NASA has looked into is commercial option. Now maybe like, why? Well, reality is basically going with commercial option. It allows them to achieve what we call multi-part path and multi-partner option. Benefit of that is, like, in case of a failure, they will not go back to space shuttle era where there's like they had only one option, and the moment that option failed, the end, done, go home sweet dreams. So they do not want to have that, and the primary benefit they're gonna achieve is what we call improved operational efficiency. Basically, right now if you want to do something on ISS, it literally needs to go through so much red tape, so much paperwork, so much, because again so many countries are involved, so much politics is involved. Good luck getting anything done in quick succession. So things are like planned out 2-3 years in advance, and if you know the modern progression of real life technology at this point in time, 2-3 years before you can test your system is just outdated. So flat out, the same way SpaceX and Boeing is starting to help NASA. Now you're like, why I'm counting Boeing? They have not launched it. They're gonna launch it. It's gonna be behind schedule. It's gonna be more expensive, but they're gonna launch it sooner or later. Today or tomorrow, they're gonna do it. By 2023, I'm hoping they will have at least one human mission. And SpaceX have already succeeded. And should NASA continue funding this? Absolutely. Simply because, of course, they will change the cadence, meaning how quickly they launch that will be changed. So basically, they will have, let's say, 3 missions from Dragon, 1 mission from this. So both of these puppy will keep surviving. And if in case of a failure, let's say Boeing goes boom, they have SpaceX to back it up. If SpaceX goes boom, they have Boeing to back it up. They must have multiple redundancy, so they do not have the issue of that there is only one rocket that can provide humans to ISS. And that has happened because when ISS basically put this rocket, Soyuz system went boom, there was no way to send humans there. So they literally had a scenario where ISS came very close to being abandoned, meaning everybody would have been evacuated, because if they do not keep resupplying it quickly enough, they will run out of resources. So this option has been chosen very thoroughly. NASA is like, this is the only way of doing something like this, and this will allow USA self-sufficiency. So they will never have a scenario where they're like, can Russia, can you help me? No, they never want to have that again. Now, the first option that NASA has already chosen, already started to give money for, that is Axiom. Now, benefit of this puppy is this is a small modular attachment that's gonna start attaching with ISS basically. Now, benefit of doing this, like again, this is not very small, but as in like think of it size wise, it will look more or less same as ISS. Only it will have less modules attached to the walls. So outer diameter is more or less the same, but the inner useful diameter is much more, simply because it does not have like 10,000 things cramped into every nooks and cranny, because ISS is a research lab. This is not a research lab first. This is a place where you can do your own research, or you can just be a tourist going there. So they are building it space first. They're more focusing on making sure it's very spacious, and because it will be docked with ISS, it gives them an easy start. Now, easy start, it simply means you can make a launcher module that has almost everything, but if you try to have its own radiator, own solar panel, it will take away mass away, directly from your payload, and your payload should be the capsule, because that's the part that's gonna make you money. So they want to use ISS. Now, they will have some solar panels. That should be enough that if it's not docked, it will have enough computation, enough stuff that it can act as a almost safe mode, life support kind of safe mode. And when it's docked with ISS, it has now power and cooling from the main ISS bus, which allows it to be far more capable. And then they'll keep attaching more module, and because it will directly start receiving extra power and extra cooling from the ISS, the day one, basically the moment they docked it, they can sell tickets to NASA, or have another commercial partners coming utilizing Dragon systems can dock into this puppy. So it allows them an easy start. Basically, module one done, go home, start making money, and then keep adding more modules to it. And once it reaches a certain size, and they will have final the fourth module, it should have its own solar panel and radiator. And if they achieve this puppy, then they will be completely self-sufficient. So in case ISS has to be detached from this puppy, this will not go down this like I got this, I have more than enough. It's just getting an easy start. And how the heck this company that something that took billions of dollars to make, how the heck this company is supposed to make it for cheaper? Like they are saying cost reduction of almost 10 billion dollar. How the heck they can do that? Well, they are trying to utilize what we call off-the-shelf part, because the metal part that goes into the systems, they are not that fancy. However, everything that goes inside is very complicated. For example, computation units. So the company is directly aiming for utilizing mobile processors. They say a processor that run iPhones. So they are utilizing basically ARM processors. Now you may be like, are they radiation hardened? No. What they're gonna do is have multiple of them cross-checking each other, so they can compensate for it. There is basically advanced variant of what we call ECC RAM. So they're gonna utilize that sort of system for processor also. So utilizing cheap, it's much cheaper to have 8 cheap processor versus one radiation hardened processor that cost few $1,000,000. So fundamentally speaking, that's how they're gonna achieve lower cost. And they're gonna, for power system, they're gonna utilize electric vehicle battery banks. So everything they want to use in this puppy is just copy pasted from everything. Like Display Portal is just tablets. So in case their tablet breaks, they will bring it down, replace it with a different tablet. So everything is off the shelf as much as possible, and should start building by 2024. Then look at the option number 2. This is not finalized at, as in NASA is not starting to pay them money yet, last time I checked, but it is also a very serious concern. And Sierra Space is literally a subcontract, a sub-variant of Sierra Nevada Corporation, and they're gonna utilize custom reusable capsules, meaning they have already built a vehicle. Now having this one extra vehicle is also useful, because think of it this way: if you are making a spacecraft, and how many rockets you can launch simultaneously directly depends on how many capsules you have. So let's say you have one Dragon capsule, you have one Boeing capsule, you have one this, so they have 3 options. So that gives them a bit more flexibility. And because this utilizes a runway, they can literally have hey, I'm gonna launch your payload here, but I'm gonna return mission. Think of it this way: let's say product was launched into the ISS, built on ISS, I'm saying basically space station, and it needed to be delivered in one exact location. So this will help them to basically do delivery from space, so to say. For some equipments that could be desirable, for example, let's say you 3D printed an organ in space, you want it to be delivered as quickly as possible to the hospital. The only way to do that is make sure you land as quickly closest to hospital as possible. So this will allow them to achieve that. So there is a lot of potential of having their own custom module, and they're gonna utilize inflating module exactly like Boeing system, Boeing, I'm saying Bigelow Aerospace. So benefit of that is right now our rockets are powerful, as in how many tonnage they can send into low Earth orbit. We got this. We have more than enough power. What we do not have is volume. Basically, how much of a diameter you can have, that's very limited. Now that is very serious limitation of ISS. However, if you can bypass that dimension limitation, you can actually do things. Right now there are 3D printers in ISS. It just can't do much things. Why? Because it's very small. It's inherently small. And forget about putting 2 or 3 of them. So that's the reality. Basically, Sierra Space focused on that part first. Get space in that space station. That's the first thing they are focusing on. That's why like their space stations is like they can literally start making a space station, complete space station with 2 or 3 launches, and it will have more space than ISS. So that's their selling point. It's like they're gonna have huge amounts of space, and benefit of that, this should allow them to have actual working area, basically where they can, let's say for some reason manufacturing optical fibers starts to become profitable. You want space to put your machines there. This is like, I got you, fam. I got this. That's the whole point of it. This allows them huge space in a space system, space station system, and they directly planned for a Moon and Mars mission. For example, this whole concept was built originally as a system from to act as a ferry between Moon and Mars. So humans go to Moon, then they dock this ferry, and this puppy takes them to Mars. And they designed this puppy for 1,000 days of operation. What does that mean? That simply means once you load this up, this puppy should be self-sufficient for 1,000 days. ISS is not that long self-sufficient, so you have to think differently. So that's why the space is primary thing that they have focused on, and they have a lot of enough. Again, they have actual things, actual tools to prove that they are not like, hot air. They can actually utilize things. So this would be another option that NASA is looking into, simply because this will allow them to do actual manufacturing. Now, what is the aim of all this? Well, aim of all this is basically free up NASA. NASA has a limited amount of manpower. Basically, think of this way. Let's say 50,000 people are there. But if NASA is spending time and money and just to make the rocket, the amount of people they are investing into that goes exponentially higher. So let's say for managing SpaceX, it only takes 200 people. But if they were building the rocket themselves, it will take 2,000 people to do everything. So having that manpower, freed up, having that cost savings allows them to focus on Moon and Mars. At this point in time, LEO has been taken care of. We know how to go to low Earth orbit. We got this. Low Earth orbit is like we got this. So allowing them to focus on Moon and Mars allows them to actually do things that they are very good at. And under no circumstances NASA wants to ever repeat that another space shuttle incident where you have like, one point of failure. That's why like multiple contracts, multiple launch vehicles. Even for lunar mission, they want to have multiple systems. That's the first requirement this generation. It's like you shall have 2 options. And this will actually allow us to use space for production. Make in space will become an actual thing. Like there are companies that want to do made in space. They can do amazing things in space. I specified like fiber optics, making 3D printed organs, having actual medication developments, insulin developments and all that. Like there are many things that ISS proved it can be done. Now you may be like, okay, I could not buy anything. Well, the reality was that ISS is very small. It does not have enough space or enough low cost access to itself where you can be like, hey, I can do things with it. No, it was just a trial run. It was just more of a prototype. So we got that prototype stage done. Now the next generation of space stations should allow us to actually use that. So at the moment we reach that production stage, justifying space to common public would be super easy. It's like, hey, you know why we spend money money on space? You were like, why? Well, the fiber optic cable that allows you connection, like very high terabyte connection to your home, that's been made in space. It can only be made in space because we cannot grow crystal that huge in Earth's environment. So you get that point. Insulins, 3D printed organs, all that jazz will allow us to actually utilize low gravity environment of that, not to observe Earth itself, like utilize the goddamn space itself. And cheap long-term access to projects will help other countries also. For example, NASA can lease out the contract in such a way that other companies, the part of NATO group, they can access that system. Whereas like India may be like, hey, I am willing to pay this, like our space station is like, under construction, so can I utilize your system to test our equipments for long duration testing? They're like, okay, go there. So that's a very important thing. And reduction of political control is also desirable, because you do not want to have, instead of, hey, we want to do this, hey, can you talk to Russia, hey, can you talk to Canada, can you talk to this, can you talk to that? No, you're like, this is our project, just deal with it. So that's the whole point. This is the next stage of space exploration, or at least that's what's exactly the aim of the situation. So this was my presentation on basically commercial LEO operations. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.